Okay, so this is day 13 for Mrs. Cucci's College Now Precalculus class. You should be on calculator file 1.3, linear functions, slope, and applications. So by the end of this lesson, you will be able to determine the slope of a line given 2 points on the line, solve applied problems involving slope or average rate of change, find the slope and the y-intercept of a line given the equation y equals mx plus b, or in function notation f of x equals mx plus b. Graph a linear equation using the slope and the y-intercept, and solve applied problems involving linear functions. Okay, so the slope or m of a line containing points x sub 1, y sub 1, and x sub 2, y sub 2. The way we find slope, and again, this is basic review, slope is rise over run, or the change in y over change in x. A lot of times you'll see this written as delta y over delta x, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So it should be very easy for you guys to determine slope. Again, you have been doing this since junior high, so nothing new here. Next page. All right, so we're going to graph the function negative 2/3 x plus 1, and we are going to determine the slope from the equation. So to graph that line, just swipe and click down at the bottom of your screen, and you're going to type in exactly what you see. Okay. So just by looking at the equation, if it's in y equals mx plus b form, you should be able to tell me what the slope is just by looking at the equation. And the slope for this line is negative 2/3. All right, so horizontal lines have a slope of, this is going to be 0. Vertical lines have a slope of undefined. Okay, so back in junior high, you guys probably built a slope house. I think maybe I even did it with you guys a couple of years ago. All right, this is your positive slope going up the roof, negative slope going down. This is 0, or like ground 0, and then this is undefined or no slope. Okay. All right, so determine the slope of x equals negative 2. All right, so x equals negative 2, first thing you need to decide is if that's horizontal or vertical. X-axis is your horizontal, so x equals negative 2 is going to be a vertical line. Okay, so that is going to have a slope of undefined or no slope. Next page. Y equals 5/2 or 2.5. Again, you need to decide if it's vertical or horizontal. Y-axis is your vertical axis, so your y equals is going to be a horizontal line at 2.5. So this is going to have a slope of 0. Next page. All right, so now we're going to get into applications of slope. Slope actually has a whole lot of real-world application stuff that goes along with it. One of those really important pieces is grade. Generally, when we talk about grade of a road or a mountain. Basically, it tells us how steep something is. So, for example, 4% grade means that the road rises or falls 4 feet for every horizontal distance of 100 feet. So it will decrease 4 feet in height over a distance of 100 feet. The larger the grade, the steeper the incline. Okay. Okay, so an example of that is Whistler's bobsled or luge. That had a vertical drop of 499 feet. The maximum slope of the track was at 20%. So 20% is going to be a pretty steep grade. Another example occurs with hydrology. The strength or force of a river depends on how far the river falls vertically. That should say compared, not comparted, compared to how far it flows horizontally. Okay. All right, so let's do an example of that. First thing we're going to talk about is building ramps. So building ramp for disabled. Construction laws regarding access ramps for disabled state that every vertical rise of 1 foot requires a horizontal run of at least 12 feet. What is the grade or the slope of such a ramp? Okay, so we were talking earlier about slope being rise over run. All right, so how much will we be rising? It's saying a vertical rise of 1 foot, so there's your rise. And that requires a horizontal run of at least 12 feet, so that's going to be your run. Okay? So 1/12. Now, to speak in terms of grade, we're going to change that over to a decimal. 1 divided by 12. It's going to give you 0.083, which is approximately 8.3%. Okay? So that would be a slope or a grade of about 8.3%. Okay, next page. Average rate of change. Slope can be considered as an average rate of change. To find the average rate of change between any two data points on a graph, we determine the slope of that line that passes through the 2 points. So average rate of change is simply the slope. It's just kind of written in different terms. Okay. Pardon me. Adolescent obesity. The percent of American adolescents who are 12 to 19 who are obese increased from about 6.5% in 1985 to 18% in 2008. Find the average rate of change from 1985 to 2008 in percent of adolescents who are obese. Okay, so if we're talking about finding the average rate of change for this, we need to find that change in y over change in x. So our change in y, our y value is going to be our percentages. Okay, so we want to know what the change has been. So we had 18%, and that had increased from 6.5%. And then following along those lines, 18% occurred in 2008, and 6.5% occurred in 1985. So what this gives us is 11.5% over 23 years, which if I put that into my calculator, I get 0.05%. Okay. Okay, next page. All right, this one is a long one. Credit card late fees. On February 22nd, 2010, the Credit Card Accountability, Responsibility, and Disclosure Act of 2009 went into effect. The Credit Card Act requires that card issuers make it clear to their customers under what circumstances they will be charged a late fee and the limits on these fees put into place by the Federal Reserve. The amount of late fees paid by the cardholders dropped from $901 million in January 2010 to $427 million in November 2010. Find the average rate of change in credit card late fees per month from January 2010 to November 2010. So again, it's that change in y over change in x. Our change in y is going to be our dollar value. So 427 minus 901 in millions. And then we're going to have over a 10-month period, so let's say 11 minus 1, which is going to give us negative 474 over 10, which is negative 47.4%. Not percent. We're not dealing with percents here. Okay, so negative 47.4, that is our rate of change for late fees. And notice it's negative, and it should be, because the amount of money decreased. That's why we use that 427 first. Okay, the amount of money that they're taking in late fees decreased. So we want that rate of change to be negative. Next page. Slope-intercept. If we're thinking about the two graphs, 3x and 3x minus 2, what we're going to do is we're going to graph those and look at the differences between them. So 3x and 3x minus 2. I'm going to add a graphs page. So here's my 3x. Notice the y-intercept is at the origin. 3x minus 2. And this time, slope is the same. They're parallel lines, but the y-intercept is at negative 2. Okay? So the difference in their equations is going to be this value here. That's my y-intercept. Okay? So if we're talking about y equals mx plus b, we're talking about the value of b. All right, so again, slope-intercept equation, that's going to be your f of x equals mx plus b. The graph of an equation in this form is always a straight line. Constant m is called slope, and the y-intercept is the point 0b, which is obviously your b value. So find the slope and the y-intercept of the line. Okay, so if we're talking about slope-intercept form, we've got mx plus b. So my slope is going to be negative 0.025, and my y-intercept is negative 0.38. Notice I'm taking the negative. Okay, next page. Find the slope and the y-intercept of the line with the equation 3x minus 6y minus 7. So this one isn't set up into the right format, so what we have to do is we have to go ahead and solve for y. So the first thing we're going to do to solve for y is get y by itself. So we're going to take this negative 6y and move it to the other side by adding. And then we're going to remove the 6 by dividing. So we get y equals 1/2 x minus 7/6. So your slope is 1/2, and your y-intercept is negative 7/6. Okay, next page. Okay, last one. Estimating adult height. There's no proven way to predict a child's height, but there is a linear function that can be used to estimate the adult height of a child given the sum of the child's parents' heights. The adult height m in inches of a male child whose parents' combined height is x can be estimated with the function m of x equals 0.5x plus 2.5. The adult height f in inches of a female child whose parents' combined height is x in inches can be estimated with the function f of x equals 0.5x minus 2.5. Estimate the height of a female child whose parents' combined height is 135 inches. What is the domain of this function? Okay, so if we're talking about a female child, we are using the f of x equation, x being the combined heights. So in this case, it's going to be 135. So f of 135 equals 0.5 times 135 minus 2.5. So this is going to be 67.5 minus 2.5. So this is 67.5 minus 2.5 is going to give me a value of 65. And in this case, it's inches. So f of 135 is 65 inches. Okay. So if we're talking about the domain, theoretically, the domain of the function is the set of all real numbers. However, if we're talking about the context of the problem, you have to kind of keep in mind that it has to be all positive numbers. You're not going to have a height of 0 or less. So what you're going to do for the domain is you're only going to choose values from 0 onward. You're not going to give a negative sum of parent heights. Okay? All right, so make sure you come in prepared tomorrow with any questions, and I will see you then.